Okay, so Leetcode practice time. Two goals in this video. The first one is to see how to solve this problem properly, and put some solid code, find a solution for it. And the next one is to see how to behave during interview. Suppose this question is given. So let's get started. See, always the first one is to understand the problem. If there's anything unclear, please bring it out to the interviewer by asking some clarification questions. And also think about some edge cases that are special. You need to take some special care of when doing the coding work. So let's take a look at this example. It's making a large island. So in a 2D grid of zeros and ones, we change at most 1 0 to a 1. So after what is the size of the largest island? An island is a 4-directional connected group of ones. Alright, so it means, okay, so 0 means water and 1 means land. And we can turn one grade of 0, like we can turn one grade from water to land to connect more lands together to make it larger. And it is asking us what is the size of the largest island after this kind of operation. Okay, so let's see, the input is like this one, output is 3, and change 1 to 0 and connect 2 ones, and then we get the island with area of 3. Okay, makes sense. So let's see some notes. So it's guaranteed that the 2D grade is not gonna be empty, so we don't need to take care of like something. What if the thing is empty? So not that special task case to think about. And also each piece is going to be each grade is going to be given either 0 or 1. Alright, so in this case, I think we don't have any special edge case we need to think about, because the notes has already clarified the edge cases. So let's go to the next step, which is about finding the solution. This part is about thinking ideas how to solve this problem and do some proper time-space analysis. Let's see. So for this one, a brute force solution, of course, is to try every bit, and then after you so for each try, you turn the 0 to 1, and you search for the largest piece. But for this one, suppose the grade is going to m by n. It's a m by n grade, then it is going to be o to m square and n square, which is horrible regarding the runtime. So let's see if we can do it better. So actually, when we use recursion or DFS to visit the lens, we can also keep record of the size of the corresponding land, so that when and after we have this, after we have the record about the size of each piece of land, and we go through every bit of the water and see the neighbor, and see all of this neighbor lands and see how much we can get. So we just need to add up all the size of the land for each of its neighbor plus the current bit, which is 1, and then try to see if that will be the largest one. But one thing we need to think about is, supposingly there is a bit. Let's take this example. Let's say 1 0 and 0 1. So this one, I think it's okay, but for this one, because for this bit it has two neighbors, this one and this one. So the size of this piece of land, excepting this 0, is going to be 3. If we add 3 twice, then it's not going to be good. So we need to think about a way to index the separate lens. So the way is, when we do DFS, try to expand the separate lens, you can give it a separate index for it. Let's say for this one, when we try to iterate through, when we try to expand and see how large this piece of land is, we just try to set it to a different number, which is the index of this land. So after we traverse through the whole grade, and we try to see the neighbor of this water, we will see, okay, this one, for this neighbor, the index of the land is 2, and we add up the 3, which is the size of this island, and when we see this neighbor, since the island with index 2, we have already add up to the total value, to the total size of the island, then we need to omit it. So that's the way how we solve this problem. So in general, this for this approach, the overall runtime is going to be m/n. So I think this should work. Let's give it a shot by doing some coding work. So for the coding part, it's more about your correctness of the code and the readability. Of course, you shouldn't be too slow. And let's give it a shot. So let's say we just so first of all, we need to define a DFS thing. But okay, so first of all, so let's say we need to give it the index. We need to give the index of different of separate islands. So let's say the index that was 2, and we iterate through each grade. I is equal to 0, I is smaller than grade dot. So why don't we just define the row and the column? So let's say row is equal to grade dot length, and column is equal to grade dot 0 dot length. So we iterate through each grade plus I for int j is start from 0, j smaller than the column, plus j. Alright, so if this is a piece of land, if grade I and j is equal to 1, then it means we need to call DFS on top of it. So we will define a helper function, which is DFS. Try to expand as much as possible to search the boundary of the current island, and also at the same time we need to keep record of the size. So let's say we define a private integer size. Yes, so we define a parameter, let's say island size. Alright, so here we need to, of course, why do we define it as a class level? It doesn't need to be it needs to be like that, because we definitely need to do it in the DFS thing. So island size is initialized at 0, and we call DFS DFS is operated on the grade, and we are doing it on the row and column. So after that, so let's say we define the DFS thing, private void DFS, so grade and row int column. Alright, so suppose after we call the DFS, we already have the size of the island, then we need to, okay, so we need a hash map here. Integer is the index of the island, and the value is the size of the island. So let's say island size map. So here we are going to say, okay, island size map dot put the index. Okay, so we also need to pass the index into it. Otherwise, we won't know which index the island belongs to. So we will put the index as the key, and the value is the size of the island. Alright, so let's see how to implement this helper function. We are going to have an index here, okay? So int, let's say if if grade row or column, let's say if row is larger, okay, so if grade row and the column is equal to 0, then it means it is water. We just need to return it. So that's the exit of the the recursive function. And then what we would do is we would say, okay, grade row and the column is set as index, and we need to plus the island size. And then you're going to call if the row is -1 is larger or equal to 0. So if row is larger than 1, larger or equal to 1, or it's larger than 0, okay? So we just say, okay, DFS grade row -1 column and index. Similarly, so if row is smaller than grade dot length -1, then we would say, okay, we call DFS on top of grade row +1 column and the index. Okay, if column is larger than 0, then we call DFS grade row column -1 and the index. If so, we are trying to expand from to the all the 4 neighbors. If call is smaller than grade 0.length -1, then index. Okay, then we are going to call DFS grade row column +1, which is the right neighbor with the index. Okay, so let's see. In this DFS function, this is the exit of the recursion. and it's saying this. So currently this is a piece of land, and we are going to set the index on top of this grade, and we are going to plus the island size. Sure. And also we are going to get into its neighbors if possible. Okay, so I think we are done with this DFS function. The next thing is to go through this 2D array again and see, and if it is water, we will search its neighbors to see to see how much of how large of a bigger island we can possibly get. So we will iterate through this again. If I is equal to 0, I is and okay, so I think, by the way, I think we need to have, let's say, max connected island size as equal to 0 at this time, and we will put let's see, so every time after DFS is called, it shouldn't be outside here, it should be here immediately. I don't know why I made this mistake. So max connected island size is equal to max island size so it is island size and maximum connected size. Okay, and then we will iterate through the grade again. So j is equal to 0, j is smaller than column plus j. Okay, this is the time we are going to see the water. So if grade I and j is not equal to 0, then we just continue, otherwise it is water. So we can possibly say, okay, so first of all we need to define a set integer scene, let's say scene island new hash set. Okay, so first of all, at every grade we need to clear it. So scene islands dot clear. Okay, so if we are going to iterate through its neighbors, so actually the neighbor thing is covered here. We can possibly reuse some function about it. Let's see how to do it. Alright, so you could possibly reuse this. Okay, so we could define another function. Let's call it get neighbors. Passing the grade and the current position. So similar. So not really. So let's say if it is a list of the integer, list of okay, list of the int array. So list int array is neighbors new linked list. Alright, so if row is larger than 0, then we will put neighbors dot add a new hint. So it's gonna be, alright, so let's say just int neighbor. No, let's just put a new thing into it. It's gonna be row -1 and column, okay? And if so, we can just copy it here. The condition should be the same, just different things to put into it. So okay, this one it's row +1. This one is row and column -1, and this is column +1. Alright, so here you're going to say, okay, for int which is the let's say, how to call it, position, okay? It's going to be get neighbors of the grade, which current position is row and column, and we are going to call DFS on top of this one, so grade, and position 0, the pole position 1, and the index, okay? So we can save all the code here and reuse this helper function. So get neighbors. We are going to going through all of its neighbors. So for get neighbors, okay? Alright. Okay. Get neighbors which we are going to pass the grade, and row, and column. Okay. It's actually I and J here. Alright, so you're going to get the current position of it. Okay, so if what is that? So if grade neighbor 0 and the grade let's put it outside. Let's say neighbor row is equal to neighbor 0, and neighbor column is going to neighbor 1. So we will have neighbor row, and so if neighbor row and neighbor column, if this one is not a water, so if it is water, we just continue. Otherwise, if it is water, we continue. Or if scene islands dot contains, if it contains this one, then we just simply continue. Otherwise, we would say, okay, so we would define a connected island size as equal to 1. Alright, which means we are flipping the current position from 0 to 1. So we are going to say, alright, so we connected plus equal to island size map dot get what is that? It is the grade. Alright, so it's this one plus equal to that, and we are going to update the scene islands dot add grade. Alright, so we are going to add into it, and after that we need to say, alright, so max is going to be updated if connected island size is larger, and then finally we return the max connected island size. Alright, so that's pretty much it about this piece of code. So let's do some sanity check by using some example. Let's say let's use this example 1. So let's see, so first of all we are going to initialize maximum connected island size as 0, and island map is going to be a empty thing, index start at 0, and the row is equal to 2 and column is equal to 2. So we iterate through every piece. So first of all we are going to see the upper left corner, which is a 1. Then we call the DFS to expand as much as possible, and we put 2 as a key and island size as 1. And similarly we are going to do it for the bottom right corner, and maximum connect island size is going to be 1 currently. And after that, this one is the upper left corner is going to be updated as 2, and the bottom right corner is going to be updated as 3. Let's see. For the get neighbors, is it going to be wrong? Okay, so we missed the return value. Of course it's not going to work properly. Okay, so let's see, if the row is larger than 0, we just see its upper corner, the upper neighbor. If it is okay, the bottom corner, the bottom neighbor, and the left neighbor, and the right neighbor. Alright, it seems to be good. And in the DFS function, this is the exit, and if it is equal to a 0, if it's equal to 0, then we simply return. Is it possible that we get into something that is not 0 but definitely not a 1? If it's 0, what is, so if it is, okay, so this one, I think the exit function needs to be updated. So it should be, if it's not equal to 1, then we just simply return. Otherwise we may need to, this may be a dead loop because we keep updating the current grade with index. So let's see, if it is not equal to 1, which means either it is a water or it has been visited within our DFS function. Okay, so the grade, we are going to mark the current grade as index and the plus the island size, and then we are going to go through all its neighbors and then do a visit of these neighbors, the possible neighbors. Alright, this seems to be fine. And then so we are done with this piece, and the island size map is going to be updated with a key as 2, value as 1, and another one. So it will be something like this, like 2 1 and 3 1. Okay, let's see, so we are going to iterate through everything. If it's not water, we just continue Otherwise it is water. We just first clear this set, and the connected island size is equal to 1. We are going to see our neighbors, the neighbor row, neighbor column. So if the neighbor is a water, or it has been seen by within the scene islands, then we simply return continue, and otherwise we are going to plus the neighbor size. So suppose we are on the upper right corner, which is this one, so it has 2 neighbors, with no water, so collected size plus equal to this neighbor, which is equal to 1. So connect to this neighbor, the left neighbor, which is this one, with index as 2, so current island size is going to be 2. And then similarly for the bottom neighbor, with index 3, and we plus another 1, so the current connect island size is going to be 3. So the scene island, and then we are going to update the maximum connected size as 3. Okay, so it seems to be right for this example, so let's give it a shot. Okay, so why? Okay, so some typo here. Alright, so bad operation. So okay, so another typo here. Alright, so runtime arrow index outer boundary, which is on line 42. So why? Okay, so it is another typo here when we call the DFS function. It's a non-pointer, 86. So get neighbor grade. How? Dot get grade. Why it is a non-pointer? At line 86. Driver solution dot. So if it is a water, or if it is within the scene islands, then we already continued that. Which means if it is not going to be water, and the scene islands hasn't contained it. But why this would be something wrong? So let's see. So at this moment, it's a non-pointer. The driver solution dot, so 54, line 54. So it says it is a non-pointer exception. Why it is a non-pointer exception? Island size map is already initialized. Get, so which means this one is not. So for this test case, this one is actually not there, the grade neighbor. So if this one, if the grade neighbor row or grade neighbor column, okay, so let's say the index would be equal to grade J, okay? If index is equal to 0, or if it already contains this, we are simply going to continue. Otherwise, we will need to get the corresponding index for it, and scene islands is going to add the index, okay? Sure. is compile arrow. Oh, okay. Index. We have maybe we have already defined the index somewhere. Let's see where. Okay, so this one, it's already there. Let's see, this island is already defined in it shouldn't be, because it's a local variable. Why it says something like redefinition. So it is in so this one, let's say if you call it island index, if it island index is 0 or island index is this one, still a runtime arrow, which is 80, which means the island index doesn't exist in the island size map. Let's see why. Oh, okay, so actually we plus the index here, so it means when we put into this island size map, the index has already been, the value of it has already been changed, so we need to plus index here instead. Okay, now it's accepted. We fixed a few small little bugs. Let's give it a shot. Okay, so now we are done with the code. Okay, so solution part. I would say that it would be the best solution without taking too much look at the solution actually. So for this one, we are done actually. And regarding the test case setup, regarding the testing, I haven't talked about that. So after coding, we need to go through a simple test case to explain how this piece of code is gonna work. And this is about sanity check. And after that, we need to set up some other test cases to make sure that the test coverage is good enough. So that's it for this coding question. So if you like this video, please give me a thumb up, and I will see you next time. Thanks for watching.